Today I'm going to show you how to deploy NodeJS app to Kubernetes. First, we will create the NodeJS Express app, then we will create Docker image, and we will upload that image to remote Docker repository. After it's done, we will create Kubernetes namespace deployment service to run our application. Also, we will deploy Nginx Ingress controller and create simple HTTP Ingress for Node.js. Then we will deploy the Cert manager and configure it with Letsencrypt and create HTTPS Ingress to encrypt traffic between the client and the server. Let's get started. All right, the first step is to create the folder. Let's go ahead and create the folder app, where we're gonna place all the source code for that application, including Dockerfile. All right, the next step is to initialize the Node.js application. And to do that, we can run npm init. Let's go to the terminal and change directory to the app and run npm init. The package name we're gonna call Express. The version will be 0.10, and then the last one, the entry point that we want to update. We're gonna skip description, and entry point will be server.js. And skip, and let's confirm that everything is correct. All right, and this generated one file. It's called package.json with our input parameters. All right, the next step in this video, we're gonna use the Express framework, which is the common, I think it's the most popular Node.js framework for building REST APIs. In order to install it, we need to run npm install and then Express, and it's gonna install the latest version of that module. Let's take a look. So we have the dependencies now here. All right, and it also created the package.log.json file. Okay, so now it's time to create the application itself, which is the server.js. Let's create that file. And let me copy paste the source code. And like I said, it's very simple application. Here we're gonna import the Express framework. Then we're gonna define few variables like port and host. And also we're gonna create only one single endpoint, which we will call DevOps. And when the client will hit that endpoint, it will get hello world in response. And then finally, we're gonna start that application. All right, let me save it and let's just quickly test it locally. Let's go to the terminal and run node and then the server.js. And let's split the terminal and use curl to test this application. Okay, let's use curl, localhost port 8080, which comes from here, port 8080, and then the endpoint, which is DevOps. And okay, looks like it works. All right, let me close this, cancel. Now, since we're gonna deploy it in Kubernetes, we need to create the Docker image. And to do that, first we need to create the Docker file. And it's gonna be very simple Docker file. And in order to reduce the memory footprint, you can use multi-stage Docker build, but in this case, it's gonna be one single stage. We're gonna use the node and then define the working directory, then the copy package.json with all dependencies, and then we're gonna build and install those packages. Finally, we're gonna copy everything from the local directory to the Docker image, and also we're gonna use the special. Well, it's not special. We're not gonna run it as a root. We're gonna use the node user, which is provided by this image itself. And finally, on the line 13, we're going to define the entry point, well, the command that will start our Docker image. All right, so that's done. And also to improve, we need to create, and especially with Node.js, we need to create the Docker ignore file. It's similar to git ignore, but let me paste first and I'll explain what's the difference. And we're gonna provide some folders which we don't want to copy from the local directory to the Docker image. For example, when you develop something locally, most likely you already have those modules like Express and all other packages. And at this point, when you already install them, you're gonna copy everything from local directory. And this Docker ignore will ignore those files that are defined here. Otherwise, it can just rewrite your packages. So that's very useful file that you can use to avoid any issues later on. All right, so that's done. Now let's go ahead and build Docker image. Let's go to the terminal and run docker build. Then -t provide the tag and name of the image, version. This -f, you can provide the Dockerfile. Well, by default, it's a Dockerfile, so it may not even necessary in this case. And the final argument is the dot, which is the directory, the current directory, the context for that Docker image. Okay, let's wait maybe like 5 minutes, and then I'm gonna continue from there. Okay, it's finally finished. And now we can list all the Docker images that we have locally by running the following command, docker images. And that's the one that we used as a base image, and that's the one that we just built, and it's quite large. And like I said, you can use multiple strategies to reduce the size of that image, but I'm not gonna do it in this video. All right, so that's done. Now, when we have the image, well, since we want to deploy in the Kubernetes cluster, which will be located in AWS, so we need to upload that Docker image to remote repository where we're gonna keep our Docker images. Well, for this video, I'm gonna be using the AWS, and I'm gonna create. You can use Docker Hub. Well, it depends where you wanna deploy it, right? So in AWS, you have the option to use Elastic Container Registry and upload your Docker images there. Okay, let's go ahead and create the private repository, and let's give it a name Express. And everything else we will leave as is. So let's create repository. And well, here actually, if you don't know how to upload the images, on the top it's very useful command that you can use. For example, let's go to the Express, and you can click on the view push commands, and this will tell you how to upload the image. And first of all, you need to log in, use this command to log in to be able to upload images. Go to terminal. Well, I copied this command. Go to the terminal, and then let's run it, and it will authenticate. And yeah, login succeeded. All right, so now it's done. This one is ready. And now we need to tag images and then push images. All right, so let's tag the image. And we're gonna tag our image that we just created, which is Express 0102, the one that we just created in AWS. So it's very quickly, and if you run Docker images again, so you will see that you have this image and that image, which are exactly the same. By the image ID, you can compare that. Those are identical. And we need this image to upload it to the remote repository. And now we can use the docker push command. Let's use docker push, and then we're gonna use that image that we just tagged. And well, in one case, it's gonna take maybe 10-15 minutes. It will depend on your internet speed. So let's wait till it's finished. All right, this step is completed. We uploaded the Docker image to remote repository. Now it's time to start with the Kubernetes. Let's go ahead and create the folder K8s. And in that folder, first of all, we're gonna create the express.yaml file. Let me close this, and let me paste the definition. Okay, so this file will consists of the namespace. We're gonna create a dedicated namespace, which we will call staging. Then we're gonna create the deployment in that namespace, and we're gonna create 2 pods, 2 replicas. And we will use our Docker image that we just uploaded to AWS. And also define some resources, which is the optional. And also the third item here will be the service, which we will use. This is just internal mechanism to load balance traffic between the pods. And we will use the service to create the ingress. All right, so let's go ahead and apply all those objects to Kubernetes. Right now I have just vanilla Kubernetes cluster that I just created in AWS, which is the managed service called EKS. All right, let's change directory back, and then let's apply that file. And you can use kubectl apply specify -f file, and then that's the file that we just created. All right, so those resources were created. Now let's just take a look quickly on the pods in that namespace, in stage namespace. So 10 seconds ago, and all of them are running right. So since I don't have any health checks, all right. And also we created the service. You can get the service by typing kubectl get svc in the staging namespace. All right, so well, right now we deployed our Node.js application to the Kubernetes, which is located in the AWS. And right now we don't have the Ingress, but we still can test it locally. And we can port forward the port 80, so you can run the kubectl, then provide the namespace where you have your service. It's a staging namespace. And then command, which is port forward, and then svc stands for services, and then the name of the service, that's the name. And then it will port forward the port 8080 in AWS to localhost. Right, let's run this. And let's split the screen again. And now we can run the same command curl, but in this case, it's gonna actually access the service in AWS. And you can see that it works. All right, so let me close this. All right, the next step is to deploy the Nginx Ingress controller. And I have the video on how to create that ingress, but in this video, I just quickly create the file and paste the YAML definition. All right. Well, if you want to know more about the ingress, you can take a look on another video that will be in the description. Right, let me create the second file. And let me paste the definition. All right, so it's quite large, 300 lines. And let's quickly take a look. So we have the dedicated namespace, Ingress Nginx, service account, config map, cluster role, cluster role bindings, etc. And finally, we have the service. And this is important because this will create the load balancer in AWS, which is will be network load balancer. And also, well, this is the controller itself that will be deployed, and the class will be Nginx. All right, so that's pretty much it for this video. Let's go ahead and apply that file. Let's apply pretty much the same thing, but the second file. And like I said, create a bunch of objects in Kubernetes. Okay, first of all, let's take a look on the pods. Nginx pods. So it's almost ready. It's status running. Let's take a look again. All right, so it's ready. And another part which is important for us is that it will create external load balancer. So it's not going to be internal, it's going to be external, and applications, well, you will be able to access the service using this external load balancer. So that's the one that was created in AWS itself. And this is the DNS name, and we will need to create the CNAME record to point to that CNAME name later on. Okay, so that's that. And when we already have the ingress controller. Now let's go ahead and create ingress for the service. So this Nginx Ingress is the system resource, but here the next file will be actually Ingress for our Node.js application. Let me copy paste, and that's the one. So it's gonna be type of Ingress, then the namespace staging. That's important part, a class Nginx that I showed before. And well, then you also need to provide like some kind of DNS name that you want to use. In my case, it's gonna be my own AntonPutra.com domain, and this is the subdomain that I'm gonna use for this Node.js application. And that's the next step is, well, that's the service which comes from here. That's the service name, and also the port 8080. All right, so that's done. Now let's go ahead and create this ingress. Let's go back to the terminal and apply this ingress. Okay, ingress was created, and to list all the ingresses, we can run the kubectl get eng, and then in staging namespace. And it takes some time to actually display this DNS of that load balancer. And if you don't want to wait, you can run, well, again, get services in Nginx, Ingress Nginx namespace, and this is the load balancer that you need to use to create the CNAME record. All right. And I also wanted to show you that before you even create any records, CNAME records, you can test it locally without creating. So you can, first of all, you need to get the IP address of that load balancer. Let's use NS lookup, and let's grab this DNS name and let's resolve it. So we have the, well, two addresses, IP addresses, and you can use one of them. So let's use another command, curl. So here you can use the curl command, but since we don't have the CNAME record just yet, you can pretend that this domain will be resolved to the IP address that you're gonna provide. So for example, here instead of IP, you're gonna select, for example, this IP address, and then it will pretend that it will be resolved to this address, and then try to access this express.antonputra.com/devops endpoint. And well, let's try, but usually when you create the ingress and then the ingress resource, it takes, well, first of all, it takes some time to initialize create that load balancer in AWS. So it may take maybe few minutes, up to 5-10 minutes maybe, to actually you will be able to access that load balancer. So let me try it again. But yeah, just let's wait a little bit, maybe like I said, 5 minutes, and then let's try to access this domain and this IP address again. Okay, let's try to access it again. And well, we're still not able to access. Let's just verify quickly. Let's run NS lookup again of the DNS. Well, right, so I think we have the wrong IP address. Okay, let me just use this IP address now. And that's our command. That one, in some reason, disappeared. All right, so let me use the one that we just have right now using the NS lookup. Okay, so let's resolve it again. Oh, well, now it works, right? And now, well, when we verify that it works, we can now go ahead and create the CNAME record. And when you're creating the CNAME record in AWS, when you're using the load balancer, you should not use the IP address. You should use the DNS name itself, because the IP address can be changed. And I purchased my domain through the Google domains, so I'm gonna go navigate. Let me grab this load balancer first, and I'm gonna navigate Google domains, and let me create the CNAME record. I'm gonna use the 5-minute TTL domain, which is the DNS name of the load balancer, and here I'm gonna specify my Express subdomain. Okay, let me add this. All right, so it says that it takes up to 48 hours, but usually it takes a few minutes. And okay, so now let's go back to the terminal, and we can use the ns lookup to resolve our domain. And if we're gonna do it right now, so we don't have the record just yet. So let's wait another maybe 5 minutes, and then let's try to resolve this DNS again. Okay, let's try to resolve it again. And now we have the canonical name, which is the CNAME record. And now let's test using curl. And right now we're gonna be using the HTTP, and in the next step we're gonna deploy the Cert manager and establish secure connection using the HTTPS. All right, so let's use curl and hit the DevOps endpoint, and we can see that we actually can access the Node.js application in Kubernetes, which is good. All right, next step is to secure it. And to do that, like I said, we're gonna deploy the Cert manager. And let me create first Cert manager. And that one is huge, so let me paste it. Okay, so it contains 26,000 lines. So because it has the custom resource definitions and bunch of stuff. In this video, we're not gonna go over all of those, and I will create another video describing tutorial regarding the Cert manager. But for this video, we're just gonna deploy it, and we're gonna create the issuer to interact with the Letsencrypt. Okay, let's save it. And this is, like I said, this is internal tool that we'll use to get Letsencrypt certificate and use it in our Ingress. All right, let's go ahead and apply this file. Let's go to terminal and apply cert manager.yaml. All right, so it created a bunch of resources. And first of all, let's go ahead and list the pods in our namespace, in Cert Manager namespace. And we have 3 of them. And this is the most important one. So if you have any issues, the certificate is not working or something else, in order to debug, the first, I would recommend to take a look on those logs and try to find any errors in the log from the Cert Manager itself. All right. Okay, so now, well, this is the generic tool that can interact with the certificates, manage certificates for us. But we need to create something called issuer to configure it with the Letsencrypt. So let's create a new file. Let's call it issuer.yaml. And let me paste the file. So that's the file. And there are 2 types. There is a cluster issuer and the issuer. And the issuer is the specific for the namespace. And the cluster issuer can be used in any namespace. So I'm gonna use the issuer, just the issuer, and put it in the staging namespace. And also, when you're getting started, it's the best approach would be to use the staging server, because the Letsencrypt has the strict limits on how many certificates you can get in 1 week, for example. So I would suggest using the staging server to test, and when you make sure that it's working, you can use the production one, and that's the production one. And you also need to provide your own email here. Then you're gonna say where it will create those secrets. And solvers, usually you have the HTTP solver, which will create the endpoint that Letsencrypt can access and verify that it's your domain. And also you can use DNS resolver as well. And here you're gonna provide the Ingress class, and this is our class that we created recently, Nginx class. All right, so this is the production one. So if you're gonna use this one, you will not get real certificates. It's gonna be fake certificates, but at least you can verify that your, well, pipeline works. Right, let's go ahead and create this file. go to terminal and apply. Okay, it's created. And of course, it's better to verify that it's working. And you can use the describe, then the type of the resource, which is the issuer, and then the name of the resource. And you should be able to see that the status is true and is ready. So this issuer is properly configured to talk to Letsencrypt. All right, now we can use this issuer. Okay, let's go ahead and create the final file to create the HTTPS. Okay, let's close this one, and we're gonna call it the HTTPS Ingress. And it's very similar. It's gonna be the kind Ingress, namespace staging, different name, HTTPS. Here it's exactly the same Nginx class, but this one since we just created the issuer, which we called Letsencrypt prod, so we need to use that one. And if you use cluster issuer, you need to write cluster issuer instead. Then it's pretty much the same rules. And here additional block TLS, which will indicate what domain it will need to get certificate for, and also where it will keep that certificate and private key. All right, and okay, let's go ahead and apply it. Okay, it's created. Now let's take a look on the ingresses. And well, right, so we just created this ingress, and it also will create additional ingress, which called Acme HTTP solver, which is the temporary. It also will create the temporary port to respond to the Letsencrypt. So it's temporary ingress, which will disappear after Letsencrypt will verify your domain. And yeah, and also you can verify by typing kubectl get certificate and in staging namespace. And you can verify that it should be true. If it's false, something wrong. But right now it's true. That means everything is well, we were able to get the certificate from the Letsencrypt. And finally, we can actually hit the HTTPS now, Express, and then, well, DevOps the endpoint. All right, and well, it works, HTTPS, and we don't have any errors. All right, and like I said, if you're not able to access it, then you would need to get the logs, for example, kubectl, get ports in Cert manager, and then you need to check the logs, kubectl logs -f to follow logs, the name of the port, and then the Cert manager namespace. And you should see some errors if you're not able to get the certificate here. That's all for this video. Thank you for watching, and please like it and subscribe to my channel. Thank you. Bye bye.